KCL. Hello class, my name is Mohammad Anzar Mattu. I'm from GNK Electronics and Hardware Trade. Today we will discuss Kirchoff's current law, shortly known as KCL. Since we know Kirchhoff has given two laws, one is KCL and other is KPL. The KCL deals with the currents in a node or in the branches, where a node is a point in the circuit where one or the more branches they come together and form a node. This is called as node, and the KCL suggests that the algebraic sum of voltages, the algebraic sum of currents in a circuit at a node is always equal to zero. So let us start with the lecture. Here is the statement for the Kirchhoff's law. As I'm going to read it, so and I will explain it along with the reading. Kirchhoff's laws are one of the fundamental laws that find application in engineering, electrical engineering for formulating the circuits. The two laws that made up the Kirchhoff's laws, and they are Kirchhoff's current law, KCL. It is also called as the first law or junction rule. The principle of this law is to conserve the electric charge. So what this line means is this law is based on law of conservation of charge, which means charge can neither be created nor destroyed. How it is based on that, I will explain it further in the lecture. The law states that the amount of current flowing into a node is equal to the sum of the currents flowing out of it. For performing the nodal analysis of Ohm's law, KCL is used. So this KCL finds application for the nodal analysis. And as we can see, nodal analysis means analysis done at the node. And at nodes, only KCL is involved. What it means is incoming currents. For example, in the given figure, I1, I2, and I3 represented in blue are the incoming currents, currents that are coming towards this node. Node is a point where one or more branches meet, and at this point, I1, I2, and I3 are coming towards the node, and these are termed as positive terms. I1 is positive, I2 is positive, and I3 is positive. We can also take them negative if we consider incoming currents as negative and outgoing currents as positive. So if we can, if I1 and I2 and I3 are incoming currents, I4 and I5 is zero. As I said in the starting, KCL is based on algebraic sum at a node is always equal to zero. Algebraic sum means sum irrespective of the signs. I1 plus I2 plus I3 plus minus of I4 plus minus of I5. And their algebraic sum is equal to zero. If we take the negative terms on the other side of the equation, the right side of the equation, we can also write it as I1 plus I2 plus I3 is equal to I4 plus I5. Let me write this. We can write this as plus I2 plus I3 is equal to I4 plus I5. See, I1, I2, and I3. These are the incoming currents. We I1 plus I2 plus I3 is equal to I4 plus I5. I1, I2, and I3, these are incoming towards the node, but I4 and I5, these are away from the node से दूर. So the algebraic sum is zero, and if we say incoming currents is equal to outgoing currents, this is the basis of KCL. Now, this KCL is valid in case of lumped circuits. What I mean by lumped circuits is circuits which are practically possible. There are many circuits which can be drawn on the board but can't be realized in the physical world. Such circuits are called as non-lumped circuits. Or there are other circuits called as distributed circuits. For example, in case of towers and the hypertension lines and the distribution lines, these are distributed networks. There, KCL won't apply. It applies only in case of lumped circuits. This is based on law of conservation of charge. Let me show you how. If we, let me erase this. If I erase this all, I can say I1 is equal to Q1 upon T for time. Similarly, this is Q2 upon T because current means charge upon time. So Q I2 को मैं लिख सकता हूँ Q2 upon T. Similarly, I3 is Q3 upon T. Time interval remains same. Similarly, this becomes Q4 upon T. This becomes Q5 upon T. As you can see, T is present in all, and we can cancel these T's, and we can write, what can we write? We can write Q1 plus Q2 plus Q3 plus, sorry, is equal to Q4 plus Q5, which means incoming charge is going equal to outgoing charge. And what and thus it is based on law of conservation of charge, that charge can neither be created nor destroyed. So at any node, charge is not created nor destroyed. It is just distributed in lines. So I hope all these questions have been answered, and all your doubts will be cleared in this lecture regarding Kirchhoff's current law, which is also known as Kirchhoff's first law or junction rule. Thank you very much.